Hello, calculus students. Hope you're all having a fantastic day. Today we're going to be really tying together everything that we talked about on graphing f, the first derivative, and the second derivative of f. Now this is going to be the lesson where all these things really get tied together a little bit more than we have. So let's go ahead and get started. There's a couple of things that I would like to do. Let me turn up the brightness on the camera here. All right, there's a couple of things that I'd like to do just kind of straight out of the gate on this first example. It says below is the graph of the derivative of a function. So first off, this guy down here is f prime. F prime. I definitely want to label that a couple of times here. Whose domain is the set of all real numbers and is continuous everywhere. So it's all real numbers. Notice that the n has arrowheads, going to keep going forever. From the graph, determine the following information. Alright, so this is the graph of the derivative. So this is something that I gave you yesterday, remember? So I'm looking at this guy right here. I'm looking at the derivative, this guy right here. So where the derivative is positive or negative is going to tell me where the top is increasing or decreasing. Where the derivative is increasing, decreasing, it's going to tell me where the top is concave up or down. It'll also tell me where the second derivative is positive or negative. Where the first derivative is concave up or concave down will tell me where the second derivative is increasing, decreasing. Now that's not really insanely important. It's mainly working back up this direction. So let's look at some of the stuff we have here. So keep. Okay, so first, the intervals on which f is increasing. So I'm looking down here at this portion of my graph. I want to know the intervals where f is increasing. So if this is my derivative, real quick, to find where f is increasing, I'm going to look at where the derivative is positive. That's nothing new. So where's my derivative positive? From negative infinity to here, and it looks like nowhere else. So from negative infinity to 2. And let's go ahead and tell why. So because f prime of x is greater than 0. Now this is going to get into justifications here to justify what you're doing. Anytime you have to justify what you're doing, always use what you were given. They gave me f prime, so I'm going to use f prime in my justification. Alright? So decreasing, it's going to go from negative 2, and it's negative here, and then it hits 0. Now this is no longer negative, so I'm going to have to break this up into two pieces here. So it's decreasing here, and then decreasing over here. So it's going to be negative 2 to 0, and then from 0 to infinity. And again, that's because f prime is less than 0, right? Because BC f prime of x is less than 0. Alright? About the relative extrema. The relative extrema. Now, the relative extrema, this is talking about maxes and mins, right? So I'm looking for a max or a min. Now this is talking about the graph of the original, so I need to go one step up from here. So relative extrema, to be a maximum, I would have to change from increasing to decreasing. To be a minimum, I would have to change from decreasing to increasing. So I'm looking for f prime to change signs. Well, it only happens in one spot, and that's here at negative 2. It goes from positive to negative. So since f prime goes from positive to negative, that means f goes from increasing to decreasing, which means we have a relative maximum. Relative max at x equals negative 2. And that is because f prime of x changes from positive to negative. All right, concave up. So again, just looking at this here, I want to know where f is concave up, so I'm going to look at where is f prime increasing. Remember, where f prime is increasing tells you that your second derivative is positive, which means you're concave up. So where is the slope of this graph increasing? Well, it's only increasing in one spot, from -1 to 0. So it's going to be concave up from -1 to 0, and that's because f prime of x is increasing. Where is it concave down? That'll be where f prime is decreasing. All right, so it'll be concave down from -infinity to -1 and 0 to infinity. Here and here. And that is because f prime of x is decreasing. Points of inflection. Points of inflection are where we change concavity. So we are concave down, concave up, concave down. And that's all that happens at the points -1 and 0. So points of inflection happen at x equals -1 and 0. Now, I can't say because it changes concavity, because it gave me f prime. So every one of my justifications have to be in terms of f prime, of what I was given. So instead of saying because the second derivative changes from positive to negative, what I'm going to say is because f prime changes from what to what? F prime changes from first increasing, or excuse me, from decreasing to increasing, or from increasing to decrease. It doesn't really matter what order you put it in. Let's put an or statement in between there. Changes from increasing to decreasing, or from decreasing to increasing. That way it just covers all my bases. This just tells me that I know what I'm looking for. I know what I'm doing here. I'm trying to figure out where it changes from increasing, decreasing, or decreasing to increasing. All right? And then using all that information, we are going to sketch a graph of the function if the only zeros of f are -4 and 9. That's very, very important. All right? That means the only place it's going to touch the x-axis is that's not a 9, 0. -4 and 0. Where did I get 9 from? -4 and 0. All right? So let's do a couple of things here. Down here is going to be the graph of f. And from the directions, it just told me that at negative, let's go 1, 2, 3, 4, I'm going to touch my x-axis, and at 0, I'm going to touch my x-axis. All right, so let's bust up this thing into a couple of different pieces here. First, f prime is what they gave me, so let's draw. There's a prime right there. It's kind of hard to see from my pencil. There you go, f prime. So let's draw a sign analysis for f prime real quick. Let's see, so we have a couple of important points here, -2 and 0. And over here at 0. And we go from positive to negative to negative. So positive, negative, negative. So f double prime, that one's pretty easy to do as well. We're looking at the slope of this one, the slope of f prime. And that's going to change in a couple of spots here. It's going to change right here, excuse me, at -1. And then it's going to change again at 0, looks like. So it goes, your slope is negative to the left of -1, positive between 1 and 0, and negative after 0. So this is going to tell me increasing. This is going to tell, or increasing. This is going to tell me concave down. This is decreasing, this is concave up, this is decreasing, and concave down. Now, you will have to notice that there are some overlays here. You see this? There are some spots where these things overlap. So here's how I'm going to do f of x. I'm going to bring down all of those numbers. -2, -1, and 0. And build this information. I'm going to build this thing. So to the left of -2, I'm going to be concave up, decreasing. Alright? Or wait, I'm sorry. I just got that completely backwards. Increasing, concave down. That's what I was looking for. Alright, so to the left of -2, we are going to be increasing, concave down. Let me just put a, well, no, I don't want to do that. Let me just put concave down, CCD. Increasing, concave down between -2 and 1. So now I am decreasing. Maybe this will help. Decreasing, and I am still concave down. Between -1 and 0, I am decreasing, right here, decreasing and concave up. And here I'm decreasing, concave down. And all I have to do now is draw my graph. Now this thing told me that I have a 0 at -4, so I know I'm going to cross the axis here. And I know that at -2 I'm going to change concavity, or I'm going to change my from increasing to decreasing. So I know something is going to happen here at -2. I also know something is going to happen at -1, and something is going to happen at 0. Now remember what each of these pieces look like. Increasing concave down looks like this. Decreasing concave down looks like this. Decreasing concave up. And decreasing concave down. So that means that to the left of -2, I have a concave up piece, and it's concave down, and it's increasing. It's going to look something like this. And then I am decreasing concave down, decreasing concave up, and I cross here at 0. So decreasing concave down, it's going to look something like this. Decreasing concave up, and hitting 0, and then decreasing concave down. Alright? That's how we're going to do them. So again, I'm looking at it, whether it's increasing or decreasing, whether it's concave up or concave down, and then building it off of those 4 pieces. That's all there is to it. So, let's go on the back here. Below is the function of f. Hey, they actually gave me f for a change. And I wrote f prime still. F of x. From the graph, determine the information. Intervals on which f is increasing. Okay, so there's a lot of stuff going on right here, right? First, they give you a couple of points of inflection where it changes from concave down to concave up. They give you a couple of those, and then concave down again. They give you a couple of horizontal tangent points, and then they give you some slopes. Now, very quickly, the intervals where f is increasing, I'm looking at f. So just tell me where f is. Or excuse me, from -infinity to -3. Ding. And then it's decreasing, and then it's increasing again. Increasing from 1 to 3.5. That's just looking at it. Where is it decreasing? From -3 to 1. and then from 3.5 to infinity. Relative extrema, again, I'm just looking at it. I have relative maximums at -3 and 3.5 at x equals -3 and 3.5. Relative minimum at x equals 1. Just looking at the graph. Where is it concave up? Well, it's concave up from here to here. From -1 to 2.5, it looks like. -1, correct my negative here, to 2.5. Where is it concave down? Well, here and here. So it's concave down from -infinity to -1. And then from 2.5 to infinity. So your points of inflection are where it changes concavity. That's going to be at -1 and 2.5. And we are going to use all of that to come up with a graph of f prime and f double prime. Okay, it's a lot of information here. To help us out, let's put it into a number line. F prime of x. A couple of things here. It's where you're changing your increasing to decreasing, so let's get some important pieces here. Now you know that you're going to have a 0 at -3. So I'm going to put that here. I know I'm going to have a 0 at -1, or excuse me, +1 here. And a 0 at 3.5. And then I am increasing to the left, decreasing, increasing, decreasing. So this is actually a relatively simple graph to find. All I have to do is come over here and label -3, 1, and 3.5. I know that I am f prime, since this is increasing, since f is increasing, f prime will be positive, right? And then it's negative till you hit 1. And then it's positive till you hit 3.5. And then it's negative after that. So again, this is increasing, so f prime is going to be positive. And then let's keep going from there. F double prime. Now remember, f double prime deals with concavity, so these 2 points right here, your points of inflection, are going to be your zeros here. Zeros for the second derivative are points of inflection, so -1 and 2.5. And this is going to be where it's going to be positive or negative, so we're looking at concave up or concave down. This is concave down to the left of -1, so it's going to be negative. It's concave up in the middle, concave down on the right. So again, once you get this sign analysis done, the rest is pretty simple. -1, 2.5. It's going to be negative, so we'll be putting down like this. It'll be positive till you hit 2.5. Try and do this as good as I can. And then it'll be negative after 2.5. Now, if you notice, this graph kind of looks like a fourth power function. It's even, both of the arrows are pointing down. It's negative, it's a negative even function. So if this was x to the fourth, this would have to be x to the third. This would be x squared. And yeah, that kind of makes sense. I can handle that. All right, so just a little bit of a practice on graphing, looking at relationships between f prime, and f double prime.